My name is Josh Flaster with Bow Only Outdoors. In today's video, we're going to go over an advanced bow build from box to bare shaft tune. Regardless of the manufacturer or the brand of bow that you shoot, from Mathews, Hoyt, PSE, Bowtech, Elite, Prime, you name it, doesn't matter. We're going to cover all the tuning steps so that you can set up your own bow from the start to the finish. Now keep in mind, there's always different ways of doing things, but following these steps can get your bow shooting better than it ever has before. Not only that, but you'll carry a whole new level of confidence with you when you go up the mountain or climb into that tree stand this fall. My goal is to give back to archers and bow hunters, to continue to grow the sport of archery and bow hunting, and the easiest way for me to do that is to share what I've been so fortunate to learn. With that, let's get started.
Holy cow. I can't believe that.
That's amazing. That is one heck of a deer.
You shot your first buck.
Before we get started, if you're planning to replace your strings or put on new or non-stock strings, you're going to want to do that right now. The easiest way to do that is to take the string and the cables off one at a time and replace them with the new ones the exact same way that you took them off. Now it's important to know that the stock strings or the strings that you're replacing them with, the aftermarket strings, that they're the exact same length as the stock string and cables that you took off. So string and cables are either made right or they're not. This year I'm just choosing to stick with the stock option strings on this because I really just don't have any issues with it. The string is built well, the serving is solid, and most importantly for me, in my opinion, I liked the served end loops. Some string manufacturers do not serve the end loops, and they do it on purpose for smaller, minute adjustment to the string and cables for peep rotation and just adjusting the cable lengths. However, I like the durability of having basically the served loops on the end of the cables and on the string. Makes it seem like they're more durable and will last just a little bit longer. Now, string rotation, along with how the string is served, will actually have an impact on the natural rotation of the arrow coming out of your bow. So if your string, this is what I found anyway, if you're a right-handed shooter with a string that is twisted clockwise to tighten, when you shoot a bare shaft out of this bow, that bare shaft is actually going to spin counterclockwise out of the bow. So if you had a right helical, it would technically be working against it. However, if you had a string that was twisted counterclockwise to tighten or shorten the string, that's actually going to send that bare shaft out of a right-handed bow clockwise. Okay, so that would align with a right helical essentially. So with this stock string option being a clockwise to tighten string, technically I should put a left helical fletching on my jigs so that it aligns with the natural rotation of the arrow as it exits the bow. Now, some good string manufacturers that I've used in the past that have a counterclockwise string to tighten so that I can shoot a right helical if I choose to is America's Best Bowstring. Like I said earlier, a string is either made right or it's not. And there's a lot of good aftermarket and stock string options out there, but I'll just leave that up to you to decide what you like best. Once we swapped our string and cables, or if you're just ready to set up the bow, the very first thing we need to do is make sure that our bow is in time. Now in time and in sync, are two different things, but they're very often confused. In sync means that these cams are moving perfectly together and that both stops hit either the cable or the limb stop at the exact same time. Now, in time ensures basically that the bow is within spec and that these cables are at the right length, because it is possible for a bow to be in sync but out of time. Now, in some bows, they have timing holes in the cams, and in some bows, we just simply measure the axle to axle and the brace height to ensure that our cables are the perfect length. Now, in this particular bow, the axle to axle measurement is supposed to be 30 inches, but to be within spec, we can be within roughly 1/4 inch of that. So say the axle to axle measurement is 30 1/4. These 70-pound limbs, it might draw slightly lower than that because they're not compressed quite as much. Now, say our axle to axle measurement is 29 3/4 and it's a little bit shorter than the 30 inches. The limbs are compressed a little bit more and the draw weight might be slightly more than 70 pounds. As long as your bow is within the manufacturer's specs and your string and cables are at the right length, you should have no problems. Most bows actually come from the factory and from the store within spec and in time. But it's always a good idea to double check, if nothing else, for the confidence. To first start with the nocking point, we have to determine our nocking point location. Now, it's crucial that the bow is in time and that the cams are not majorly out of sync before we do this. It's important that the cams aren't majorly out of sync, because if we have to make big adjustments to these cables to adjust these cams, it's actually going to shift our nocking point up or down on the string because of the way the cam's rotated. We will test sync once we have our nocking point attached, because we must test sync at full draw. Now, if your bow is within spec and your string and cables are the same length as your old string and cables, or it's a brand new bow, stock strings, your cams shouldn't be majorly out of sync. They should be very close, and any adjustment that you will need to make should be very minimal and shouldn't really adjust that nocking point position very much. Now, I like to align my nocking point 90 degrees to the very center of the burger button right here. This should be an optimal position for most archers and most bow hunters because it'll give you the most clearance and the most amount of adjustment out of your rest. Now, to find perfect 90 degrees, I like to just use a Easton 90 degree tool basically to find the nocking point. If you don't have this, it's not required. If you've got a press, you can just put the bow in the press, level the string, just put an arrow nock on the string, and let that arrow point your 90 degrees straight down. You don't have to tie the nocking point exactly 90 degrees to the center of the burger button hole. In fact, some people will actually tie it slightly higher so that the center of the arrow lines up with the top of the burger button hole, essentially to give them more leverage with their pull. So once they're at full draw, they're pulling from a slightly higher point and they could run a longer stabilizer with more weight on the end. Overall, just giving them more stabilization and helping them hold steadier to activate a better shot. Now, as an average bow hunter like me, I'm just going to set it up right down the middle of the burger button hole, as it can lead to sometimes slight complications with tuning and some other problems. So I would just recommend setting it up right down the middle of the burger button hole. Now, some people will prefer to actually tie in the nocking point slightly lower than 90 degrees to the center of the burger button, potentially on the bottom of the burger button, because they're trying to tie the nocking point in the middle of the string between the cams. Now, this isn't necessarily a bad idea, but some of the complications that you can run into is that everything sits too low and you'll end up getting fletching contact on your shelf or from your rest. Now that we have our location picked out, we're going to tie on our nock sets. Now, for the serving material that I like to use for nock sets, I personally like to use the BCY 3D. I use it in a light color, in this case white. That way when I'm bow hunting and it's kind of dimmer light, I can see that easier, so I can nock my arrow quicker and just more efficiently. Now, I've also used the BCY Power Grip serving, both of these in the 0.018 diameter thickness. If you get much bigger than that, it's just too bulky on the string. But if it gets too much smaller than that, sometimes that nock can kind of slip up onto the nock sets and wear the nock sets as you shoot over time. You can find both of these in links in the description in this video. Now that we have our location picked out, we're going to tie our top nock set. It's a simple overhand knot, but it's wrapped twice to make it wrap around the string and lay cleaner as we alternate the knot on each side of the bowstring. I usually do 6 knots 3 on each side, alternating back and forth, moving up the string away from the knock. Once I am finished, I trim it to 1/4 inch and burn the rest down so that it does not come loose. If you cut it too short and it doesn't burn down well enough, it can come undone easier. That is why I like to leave 1/4 inch before I burn it down. Now that we've got our top knock set tied in and set, we're going to move to the bottom and tie our bottom knock set. Now we've got to leave a gap between the actual knock of the arrow and where the bottom knock set is tied. Now, we don't need to make this more complicated than it is, but there's several factors that will determine how big of a gap we should leave for basically the bottom knock set. So picture it this way. If you've got a relatively short axle-to-axle bow, say 28 to 30 inches, but your draw length is over 28 inches or over 30 inches, that string angle is going to be very, very tight. Okay? When that string angle is tight like that, that's going to put a lot of strain and torque on that knock of that arrow, if that makes sense. So we need to have a slightly bigger gap on that bottom knock set. Now say you're shooting a 36-inch axle-to-axle or greater target bow, and you've got maybe a relatively shorter draw length, maybe 26, 28, whatever it might be. That string angle, instead of being short and tight, it's going to be rather open. So a big gap like that isn't going to be needed. So what we need to do is find our optimal gap based on our draw length and the axle-to-axle of our bow, so that we don't have a lot of play with our knock moving up and down between the knock sets, but also so that it's not too close together and that it's pinching that knock, causing that arrow to come up off the rest at full draw. Now you'll want to tie these bottom knots exactly the same as the top knots, but what I like to do is add a few more knots on the bottom side rather than the top side, somewhere around 8 or 9 instead of the 6 or 7 that I had on the top. Now, why do you want more knots tied on the bottom than the top? Essentially what that does is, if there is just a little bit of knock pinch, what that does is it brings that arrow and pushes it down into the rest. Whereas if there's more knock pinch on the top part of the knock, essentially what happens is you draw back and that arrow lifts up off your arrow rest, which can put that arrow in inconsistent positions every single shot, every single time. So we want to be as consistent as possible. We're going to add a few more knots on that bottom side, and then we'll finish it up, cut it 1/4 inch, and we'll burn those edges down. Now that we have our gaps set, cut off about 6 inches of your favorite D-loop material. Most common is probably the BCY number 24. What I prefer is actually the BCY number 23. It's just a little bit smaller in diameter than the 24, a little bit softer, a little bit lighter, and personally I think it gives me a smoother release execution. Now that we've got our piece cut, what we're going to do is we're just going to mushroom out this end of the D-loop, because we've got to burn down one end to start. So we've kind of made a slight mushroom effect just like that. We'll take our lighter, we'll slowly melt it down. We don't really want to burn the material because it can make it weak, but we just want to melt it down nice and soft, kind of making a ball on the end just like that. What I like to do is just take the side of the lighter, just lightly press it against the side of it, just like that, just kind of to make that bulb, and let it cool. Now that's going to be basically the knot that holds that end of the rope so that it doesn't slide through on the D-loop knot. Now for the first knot, we're going to start here on the top. We're going to take our piece of D-loop material with the mushroom end. We're going to lay that over the top of the string here on this left-hand side for a right-handed bow. We're going to take that knot end. We're going to go back behind the string, wrap it around it. Now we're going to go up and over the D-loop material. Then we're going to go under the bowstring. We've just made this hole right here. That knot is going to go right back through it, just like that. Okay, so then we can take our long end, kind of snug it up right against that top knock set, pull it down. We don't have to get it super tight just yet. That's our very first knot right there. Now for the bottom side, we're going to take it, we're going to go on the back side of the bowstring. We just created this hole. We're going to go back through that hole. Okay, and I like to pull it kind of tight just to give me more string to work with. Okay, and since our top knot ended with that burnt end facing away from us, we've got to have this bottom knot facing up. So we're actually going to go up over the bowstring this time, and we've created this hole. So we're going to take this tag end, go back through that hole, and pull it tight, just like this. Okay, so that's kind of our starting position. And I'm going to take my D-loop pliers, and we'll put it through the D-loop in the string just like this. We're going to stretch that out roughly to 3/4 of an inch, just like that. Now we're going to take our knife. We'll cut the tag end. We don't have to leave it quite as long, just roughly 1/8 of an inch, so we've got enough of it to mushroom. So we've got that, kind of mushroom it out a little bit, just like that. Take our lighter, slowly melt it down. Careful not to necessarily burn it, just melt it. Okay, also careful not to touch the rest of the D-loop, make it weak. And we'll just mash it down with the lighter, just like that. Okay, so both knots are set. I'll take these knock pliers again, and I'll just stretch that out, make sure it's good and tight. And you can see that that's roughly 3/4 of an inch right there. So why do we want our D-loop at least 3/4 of an inch? Well, if you're shooting any kind of handheld release, this is very important because when you draw back and then you twist your hand to come into anchor, it also twists that D-loop. If that D-loop is too short and too close to the string, you've got a lot of added pressure on that string in the let-off when that string doesn't have a lot of tension on it at full draw. This can cause a lot of inconsistencies, not only because the string is twisting at full draw, but it could also mess up your peep alignment with your sight because it's actually twisting and moving that string to the side. So it's just to keep the consistency with it for a handheld release, make your D-loop at least 3/4 of an inch long. If you're shooting a wrist strap, it's not necessarily required, but I would still recommend at least a 3/4 of an inch long D-loop. I don't like getting a whole lot longer than that, just because I just like having mine set at 3/4 just to match up with the draw length that I have on my bow. Now that we've got our knock sets and our D-loop tied in, we can move on to double checking our timing and now synchronizing our cams. Okay, at this point, we have replaced our string and cables, we've tied our knock set in D-loop, and we've double checked that our bow is in time. But now we're ready to double check and set the sync of the cams. But what is timing the cams and what is syncing the cams? Why are they different and how does that work? So timing is the cam position at rest and the rotation position at full draw. If our cables are too long or too short, this cam on the top and bottom will be either under rotated or over rotated. Now synchronization is ensuring that the stops on the top and the bottom cam are both coming around and both contacting either the cables on this particular bow or the limb stop on limb stop bows at the exact same time. Now again, it is possible that your cams can be in sync with each other, but the timing position can be off. So it's important that we check both by ensuring that the timing is on by making sure the bow is within spec and by using the draw board to ensure that the top and the bottom cam are in sync with each other. Now every dual cam, binary cam, hybrid cam bow essentially needs to have these stops contacting the cables at the exact same time, at least for the starting position for tuning. The only exception to this would be the single cam bow, which most companies are slowly starting to fade away from because they can actually create just more tuning problems in general and are generally less efficient. On bows with timing marks on both cams, if the cams are visibly in time at rest, it's usually in sync at full draw, but it's always a good idea to double check in a draw board. We will use our draw board to check the sync in our cams and see if there's any adjustments we need to make. Before I do that, on this particular bow, I'm actually going to change the percent let off from 85 to 80% just for my personal preference and shooting style. Now if we put our bow on the draw board and we've got a gap with our top stop hitting the cable and our bottom cam is hitting the cable, that means our top cam is slow. Okay, so we've got a gap in the top cam. So personally what I like to do is put a twist or a half a twist into this bottom cable to basically slow down this bottom cam to match the rotational speed of this top cam right here so that they both hit together. Now it's vice versa. If we have a gap in the bottom cam where that stop's coming around to hit that cable and the top is touching, now the bottom cam is slow. So what I prefer to do is go to the top cable and tighten or shorten that cable to slow down the top cam to match that bottom cam. Now you can take twists out of the cables if needed, but generally you have more control when you add twists to those cables when making the adjustments. Now if you're already short on your axle to axle and you feel like you should take a couple twists out, feel free to do so. Now if you do choose to take twists out of the cable, you must do it from the side that the gap is on, if that makes sense. So say the top cam has the gap. Instead of tightening this bottom cable, you could actually take twists out of this top cable, basically taking this slow cam and speeding it up by turning that rotational position so that stop comes into contact with that cable or that limb sooner. So now it's time to install our arrow rest and set the center shot on this bow. Now I strongly prefer drop away arrow rest just because there's no fletching contact if it's set up correctly, whereas something like a whisker biscuit, prongs, any other type of arrow rest, you just usually have more problems with fletching contact and things of that nature. Now there's two different kinds, or two main kinds of drop away arrow rest. One is a cable driven rest, which would be this style, the Hoyt QAD Integrate arrow rest. The other style would be like a limb driver arrow rest, something like a Vapor Trail, a Hamskea, something along those lines. So what are the differences between those two? Which one's better? Which one has more cons, etc., etc.? In my opinion, it's basically personal preference. Whatever you choose to shoot is what's best for you. There's both pros and cons to a cable driven and a limb driven rest, but it really honestly all comes down to pros and or your preferences. So with this cable driven rest here, what that means is that this cord is going to come down from the rest attached to the downward cable. When I draw back, that cable goes down, it lifts that rest all the way up, supporting that arrow. Now when I shoot and that cable goes up, it drops the rest because it's spring loaded. As far as a limb driven rest goes, when you draw back, the spring in the rest lifts those blades up, supports that arrow, and then when you shoot, it pulls that cord down from the limb expanding down, and so it forces that launcher down, get out of the way of the arrow as you shoot. The only bigger disadvantage to a limb-driven rest than the cable-driven rest, in my eyes, is the extra cord that is going down to the limb or up to the top limb, depending upon the limb-driven rest. It just seems like since there's more there, it could get caught easier when you're in a hunting scenario, maybe running through the mountains, something like that. That cord snags, pulls through, you draw back, and you realize, oh no, my prongs are already up because there's nothing holding those prongs down from that string that was against your limb. And then you go to shoot, and it's not gonna fall. So the good thing about it is generally if you had a shoelace or any kind of cord, you could fix it there in the field, where this cord has got to be attached to that downward cable somehow, and generally it's most easiest done by splitting and putting it through that bottom cable. Now with the Integrate Rest system, now that we've got it mounted, you can kind of see how it mounts basically on that Picatinny type rail on the back end of this riser. Now, a few advantages to that is that it makes the rest lighter, it's a lot sturdier how it's attached there, and it's just a lot more streamlined. You don't have that rest sticking out to the side. But a disadvantage to it is the fact that we can't adjust the rest closer to the riser or further away from the riser. So why is that a problem? Well, it's not necessarily a problem, but it's going to change how we torque tune. So I'm not going to get into that right now. We're going to save that for a later portion of the video so we can go a little bit more in depth just so that you guys understand. But let's continue installing this rest. So the next thing that we're going to do is set the center shot on this rest. So center shot for these new Hoyt bows, anywhere starting between 5/8 of an inch and an inch from the inside of the riser to the center of the arrow is considered acceptable and can be tuned. Now, what's important is that you don't get any fletching contact. If it's too far inside, potentially more inside than 5/8 of an inch, you might get fletching contact up against your riser. Your sight might be too close to your riser. You might be cutting off part of the housing, stuff like that. In that case, we're gonna have to shift those spacers in the cam and make those adjustments. Now, for most bow companies out there, or just a general rule of thumb, most center shots are going to be set right around that 1/13, 1/16 of an inch from the inside of the riser to the center of the arrow. So we just went ahead, set this at 1/13, 1/16 of an inch. Of course, with tuning and everything else, we may have to adjust that slightly. The important thing is that it's within that range and we're not getting fletching contact. Don't focus so much about a perfect measurement. It's not a perfect world. Remember, we're always tuning the bow to how it shoots, not how it measures, not how it looks. Once we have our initial center shot set, we can now set our vertical adjustment. Now, honestly, what I like to do is just visually set my vertical adjustment with my rest, because I've already set my nocking point up so that the center of the arrow is in line with the center of the burger buttonhole, or basically 90 degrees or very slightly above. For most binary cam system bows just like this, that nock and that arrow is going to run a perfect 90 degrees to the string or slightly high, an 1/8 inch, potentially up to a 1/4 inch, usually never higher than that. So we're going to start just by visually setting, adjusting that rest so that the center of the arrow is right in the middle of that burger button. Once we have eyeballed our rest, we'll now attach our cord to the downward cable. Again, this is a cable-driven rest, so we've got to split basically the cable right underneath the serving here, so that when we draw back and that cable goes down, it lifts that rest up in order to fire. So we're going to toss it in the press, split that cable, and put that rest cord through it. So a good place to put this cable is right at the bottom of the grip. Okay, so on a binary cam bow, there's generally quite a bit of movement between these cables when they go down and when they go up. So we need to make sure that we have a lot of extra D-loop material coming off of this rest for our adjustment. Now on some bows and with some string manufacturers, they don't serve all the way down that cable to the bottom of the grip as a hard stop to put that cable for your cable-driven rest through. So if that's not the case, where it comes all the way down to the bottom of your grip and you need to tie a portion there to hold that cable there and keep it from slipping up the downward cable of the bow, we can just use the same knots that we tied for our knock sets here with our nocking point and our D-loop right above this D-loop cord cable coming from the cable-driven rest, right above it, so that it doesn't slide up when that cable is pulled down once we draw. Now with your serving coming all the way down to the bottom of the grip, or a knock set basically tied right at the base of the grip to stop this rest cord from sliding up the cable, what we now need to do is tie a knot at the very end of this rest cord so it creates a hard stop up against this serving or up against that knock set that you just tied to keep it from moving. So we'll just take the end of this cord and I'm just going to tie just a 1/2 hitch knot right at the very end of it, just like this. And I'll pull it pretty tight like that, and then I'll just pull it right up so that it's against that serving or against that knot that we just tied, so that cable can't go anywhere. It's tight. All of our adjustment for this cord is going to be right here in this part of the rest using that QAD rest screw. Now that our rest cord is securely fastened to that downward cable, what we're going to do is we're going to loosen this screw right here in the rest so that we can pull this cable through, and we're going to loosen it just enough so that there's still tension on this cable, but tight enough so that when we draw back, it pulls that excess cable through the rest and leaves it at the appropriate length so that that rest comes up during the last inch of our draw. With this set screw right here on the rest loose, we can now load an arrow and draw back to set the position of this cord as it pulls that launcher blade all the way up perfectly to that 90 degrees straight up and down angle as we come to full draw. We want there to be enough tension on that screw that the launcher blades comes to the full 90 degrees vertically within that last inch or two of the draw cycle. You can test this in your draw board to know that it comes up correctly within that last inch of the draw. Once we have our rest cord in the correct position verified by the draw board so that those prongs are coming up in that last inch of draw, we can now tighten that screw right here in the thumb peg to lock in that rest cord. Now, I'm always going to leave that rest cord tag end on until we are completely done with tuning, because for right now we might have to adjust that rest further up, further down, and we need to have at least some kind of adjustment so that we can adjust this cord if needed if we move that rest. So now we're ready to shoot through paper for our initial paper tuning tear. Now we're not going to get super advanced with this. This is mainly just a starting point, something to get us close. We've got a lot more advanced tuning we're going to do with this. So we've got our paper tuner set up here. There's a lot of different things that you can do to set up your paper tuner. In this case, we're using a ladder with some paper tape to it. I've used boxes in the past. I've used PVC pipe frames. I've used actual paper tuners built for it. Doesn't really matter. You don't have to get fancy with it. This ladder is right here. It's easy. Just grab some paper and some tape. We're going to shoot through it and see what kind of tear we get. Well, I hope you enjoyed this masterclass up to this point. What you just watched is a small tidbit of information to get you started setting up your bow to achieve the utmost accuracy and forgiveness out of your setup. For the remaining setup and tuning techniques, we've created the Ultimate Bow Build Masterclass online course as an educational resource to take your knowledge and skill to the next level. We've specifically designed this program with step-by-step implementation of key information presented in a clear and concise order to get to the point and give you the information that you need without the fluff. This online course features full instruction on complete bow setup and tuning with techniques that have been used by thousands of successful archers and bow hunters for decades. Visit the link in our description below to access our Ultimate Bow Build Masterclass to take your archery and bow hunting skills to the next level. As always, thank you guys so much for watching. I hope you enjoyed this free portion of our Bow Build Masterclass. If you have, please leave a comment below. And again, please check out the link in our description to check out the course on our Ultimate Bow Build Masterclass. Thank you so much for watching.